Hello and welcome you all. Today in this video we will study types of real valued function. Students, a real valued function means a function whose domain and codomain are the sets of real number. That is a function f from R to R. Here R is domain and another R is codomain. So from here we can say that domain is a subset of real number and similarly a codomain is also a subset of real number. And now our first type of real valued function is identity function. Student, a function f is said to be an identity function if fx equal to x for every x belongs to real number. So to understand it, if we put different values of x, say at x equal to 1, we get fx equal to 1, and at x equal to 2, we get fx equal to 2. So as I have already told you, that domain of function is a set of values of x at which function is defined, and range of function is a set of values of fx is called range. So from here we can say that the domain of identity function is equal to real number and range is also equal to real number. And similarly on the graph, as you can see that on different values of x on x-axis we have same values of fx on y-axis. So when we join these points we form a line, and this line will be passing through the origin. And now we will study our next real valued function, which is constant function. Student, a function f is said to be constant function if fx equal to c. Here x belongs to real number and c is constant. So in constant function, if we put different values of x, we get the same constant value which is equal to c. So the domain of constant function is equal to real number and range is equal to constant in close curly braces. So from the graph you can observe that the value of c remains fixed, and therefore a straight line is formed which is parallel to x-axis. And now our third real valued function is a polynomial function. Student, a function f is said to be a polynomial function. Let's say a polynomial function fx equal to a0 plus a1x plus a2x square plus and so on up to an xn. Here n is non-negative integers and a0, a1, a2 up to an, they belongs to real number. So to understand it, let's say a polynomial function fx equal to x square. So student, from here when we put different values of x which belongs to real number, let's say at x equal to 1, we get f of 1 is equal to 1 square which is equal to 1, and at x equal to 2 we get f of 2 which is equal to 2 square, that is 4. So at 1 we get 1, at 2 we get 4. And similarly student, if we put minus 1 we get 1, and if we put minus 2 we get 4, because the square of negative number is always positive. So from here we have observed that the domain of polynomial function is equal to a real number, and the range, which is set of values of fx, will always be positive. So therefore range is equal to all the positive real numbers. And now our fourth real valued function is rational function. So as we know that a rational number is a number which is in the form of p upon q, where q is not equal to 0. And similarly student, in function also, let's say fx equal to gx upon hx. Here hx is not equal to 0. So generally it is not possible to draw the graph of rational functions, as this is only possible with the help of software on computers or labs. So here we have observed that the domain will be equal to all the real number except zeros of hx, and range is calculated according to our situation. And now our fifth real valued function is reciprocal function. Student, let's say a reciprocal function which is fx equal to 1 upon x, where x is not equal to 0, because if x is 0 then our function will become undefined. So from here when we put different values of x, so as you can see on your screen that in this graph, when we increase the value of x, our graph will decrease, but it will not touch the x-axis. And now therefore student, the domain of reciprocal function will be equal to all the real number except 0 in close curly braces, and range is equal to all the real number except 0 in close curly braces. So practice this question, mention on your screen and submit me the solution. This is the end of this video. Thank you so much and have a great day ahead.